Mr. Ng is a lecturer invited to University Malaya to attend a seminar for 2 days. He drives a Honda Jazz 1.2 VTEC that he just recently bought thanks to his recent bonus. When entering the university, he must drive up and down several inclines, and one of the steepest inclines is along the road past Dewan Tunku Chancellor. Mr. Ng is a very punctual person, and he does not like wasting time. He drives at a fast but safe speed around 80 kilometers per hour on straight roads. On the first day, he drove in a dry, sunny day. But on the second day, it was heavily raining the night before. Thus, the roads were wet. When driving on the second day, upwards the steep incline by the historical site, he realized he got up the incline faster than the day before when it was dry, despite driving the same speed and the same car. What happened? Today I'm going to help you find that out. My name is Aiman Roslan, matrix number 171666156, and today we will be looking into a case study which studies the motion of a car on an inclined road through different conditions. The purpose of this case study is to analyze the motion of a car in different conditions, which is dry and wet roads. We will then identify the forces involved. Following that, we will identify the effect of the conditions on the forces applied onto the rigid body of which is the car. And from all of that, after we did the calculations, we can explain exactly what happened to the acceleration of Mr. Ng's Honda Jazz. Next, we look at what are the forces involved in this case study. The first force, which is weight, denoted by W. It is the gravitational force applied on the object by the gravitational field of the Earth, which is pulling it towards the center of the Earth. Next, we have normal force denoted by Fn, which is the force perpendicular to the surface contact. Next, we have drag force denoted by Fd, which is commonly known as air resistance. Next, we have frictional force denoted by Ff, which is the opposing force from surface contact, which is divided into static friction and kinetic friction. And then we have thrust force, Ft, which is the force applied onto the body by an external force. I will now pass on this case study onto my partner. Thank you.
Hi, my name is Nurul Binti Arif with the matrix number of 70113595-2. Will now present about the problem statement about our group assignment. So first is that a man weighs 75 kg drives a 1035 kg of Honda Jazz on a 20-degree incline road from point A to point B to attend a seminar for 2 days. So on the first day when he traveled, it appears to be sunny and dry. Meanwhile, on the second day, the road appeared to be in wet condition because since it had rained in the night before, and the velocity of the car is 80 km per hour. So what our group wanted to solve and wanted to find is that the acceleration and the time taken by him used by the car to travel from point A to point B in both situations. So the conditions are, on the first day, the road assumed to have a kinetic friction of 0.7, while on the second day, the road assumed to have a kinetic friction coefficient of 0.4. Next is the methodology on how we solve these problems. So first is that we analyze the problem. And the steps are, first, we find the forces that were acting on the car. Second, we constructed the free body diagram and the kinetic diagram for the above situation. Third, by using the free body diagram and the necessary formulae, we obtain the values of the forces acting the car. Last is that we calculated the acceleration at the time taken by using the forces and Newton's second law of motion equation, which is F equal to ma. So let me explain about a bit about the three learning outcomes that we're going to gain from our group assignment. Is that the first, by using the movement of the car, we can determine the problem with related to the Newton's second law and develop solutions in improving the problem. The second learning outcome is that by using our knowledge in dynamics, we have identified the forces and all possible factors that affect the accelerating rigid bodies by constructing the free body diagrams and kinetic diagrams of the movement of the car. Then we stated all the assumption values. That is, we employ all the knowledge in dynamics to analyze the kinematics and kinetics of particles. So that's it. My other groupmate will explain further about the calculation part. So thank you.
Hi, my name is Amanina Binti Razali with matrix number K10048. So today I would like to continue the presentation with the free body diagram. So as you can see here, this is the free body diagram of the forces that are acting on the car. And you can see here there are thrust force, normal force, friction force, and drag force, and also the weight and the degree of 20. So we have made a few assumptions, which are the road is inclined with no bumpers and is straight with no curves. The car is new, there's no loss in power and able to maintain constant velocity. The tires are all inflated and assume all equal friction applied or accelerates. Thus, the thrust force is much bigger than the drag force plus the frictional force. And the density is 1.2 to 5 kg over meter cube. And the cross-section area of the car is equal to the hatchback car. The drag coefficient of the car is equal to 1.05. And from this situation above, I found a few parameters, which are mass of the driver equal to 75 kg and mass of the car is equal to 1035 kg, and the incline of the dry road is equal to 0.7, and the coefficient when the road is wet is 0.5, and the velocity of the car is equal to 80 km per hour, and we convert into the meter per second, and we got 22.22 meter per second. Okay, next is the calculation to find the values of forces in the free body diagram. So first of all, we have to find in the y-axis equal to n minus w cos theta equal to 0 because there are no acceleration at y-axis. The mass of the driver and also mass of the car and with time with the g, and we've got 10 this value. We can calculate the normal force, and we substitute the value of w and also the value for theta, which are 20 degree, and if we've got the normal force is 10232 frictional force of driver. With the coefficient of 0.7, 162.69 Newton. And for the frictional force of the weight road with a coefficient of 0.4, we got the value is 4092.96 Newton. Okay, and for the drag force, we have the formula of 0.5 times with the density of the air and also velocity of the car squared, and also the cross-sectional area and also the drag coefficient. And we substitute the value and we got the drag force is equal to 1905.17 Newton. The magnitude of the thrust force needs to be greater than the total value for the drag force and also frictional force, since we assume that the car is accelerating. And for the dry road, the thrust force needs to be bigger than 9067.85 Newton, and for the wet road, the thrust force needs to be greater than 5998.13 Newton. So we have said that the value of thrust force is 9500 Newton to ease the calculation for both situations. Was equal to 9500 Newton. The weight is 10889.60 Newton, and the degree is 20 degree, and the normal force is 10232.14. And for the dry road, the frictional force is 7162.68, and for the wet road, the frictional force is 4092.96, and also the drag force is equal to 1905.17 Newton.
Hi, I am Adreen Yasmin, Zaiwanadi. So for my part, I will be explaining on the kinetic part of this real life situation. So here is the kinetic diagram of this situation, and from this kinetic diagram we can extract acceleration and also velocity. Okay, so for this situation, we want to find the acceleration and time taken by the car from A to B during dry and wet road. Okay, we know that force equal to ma, so we want to find the fx. As we can see from the free body diagram here, fx is equal to thrust force minus summation of drag force plus frictional force, and also equal to mass of car plus mass of driver times with acceleration. So we can use the formula to find the acceleration during both condition of road, but we just need to change the frictional force according to the road condition. So for the dry road, we have frictional force calculated previously, which is 7162.69. So we put inside the formula and we get the acceleration during dry road condition is 0.389 meter per second squared. And then same goes to the wet road condition. We insert the value of the frictional force during wet road condition. So we get the acceleration of wet road condition of 3.155 meter per second squared. And then we have assumption that the initial velocity of the car is 0 meter per second, and once it reaches the uphill on the B point, the velocity is 22.222 meter per second. So we can find the time taken for the car to reach from A to B by using formula of final velocity minus initial velocity divided by acceleration according to the specific road condition. So for time taken during dry road condition, we use the value of acceleration during dry road condition, so we get the value of 57.126 seconds, while the time taken during wet road condition is 7.043 seconds. And lastly, for the summary of this real life situation, we know that different road conditions have different kinetic friction coefficient, thus it will affect the acceleration of the car. We can see that during dry road condition, we have higher kinetic friction coefficient, thus it have lower acceleration, while during wet road condition, it have lower kinetic friction coefficient, thus it have higher acceleration. That is why it's dangerous to drive on a higher speed during rainy days. Okay, so when car is going uphill, there will be inclination. That means there will be angles involved in the calculation to find the forces. And in this situation, we have 5 forces involved, which are thrust force, drag force, friction force, weight, and also normal reaction force. And we can derive it by drawing the free body diagram. And from the free body diagram also, we can extract kinetic motion. I think that's all from our group. Thank you.